Hello people, welcome back to my channel, The Talk. Today we are going to look at the exercise 1.2 questions. 5, 6 and 7 will be covering 3 questions in today's video. So the first question says, check whether 6 power n can end with the digit 0 for any natural number n. So let's look at the solution for this. If the number 6 power n ends with 0, it says it is divisible by 5. So let's look at the divisibility rules for the number 5. So a number is divisible by 5 if the ones place has 0 or 5. Then it is divisible by 5. So but if you look at the prime factors of 6, let us see, because 6 is the base and n is the power, we will consider the prime factors of the base. So 6 can be expressed in the product of prime numbers are 2 and 3. So 6 equals to 2 multiplied by 3. So there is no occurrence of 5. 2 and 3 are the only prime factors of 6. This makes it clear that there is no value of n in natural numbers for which 6 power n ends with the digit 0. So only if there is 5 in the prime factors, so when you multiply it, you can get either 5 or 0. So as 5 is not there in the prime factors of 6, then there is no possibility of getting 0 for 6 power n. Let's move on to the next question. Explain why 7 multiplied by 11 multiplied by 13 plus 13 and 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 plus 1 plus 5 are composite numbers. Before this, let us look what are composite numbers once again. A composite number is a number that has factors other than 1 and the number itself. Whereas prime number has the factors only as 1 and the number itself. So examples of composite numbers are 12, 14, 16 and prime numbers are 2, 3, 5, 7, 11, the list goes on. Let's look at the question now. So we will divide this question into two parts, like this part we'll take it as part 1 and this we will be taking it as part 2. So considering the first one, I have placed brackets because there are two operations, 7 multiplied by 11 multiplied by 13. I placed them in brackets because there are two different operations, 7 multiplied by 11 multiplied by 13, these involving multiplication, and there is an addition operator. So we basically follow the Bodmer's rule for following. You know what is the Bodmer's rule, right? So B stands for brackets, O stands for off, D for division, N for multiplication, A for addition and S for subtraction. So we will start with the brackets first. So when you evaluate the part in the brackets, so 7 multiplied by 7 is 77 and 77 when it is multiplied by 13, what do we get? 13 times 7 is 90. 13 times 7 is 91. 1 plus 9. 13 times 7 is 91 again. So when you add 91 plus 9, we get it as 1000 and we have 13 now. So 1001 plus 13, it's going to be 1014. So this is part 1 and we have to check whether this is a composite number or not. So we have discussed in the beginning that a composite number can have factors as other than 1 and the number itself. So we will express 1014 in the form of prime factors now. So starting with 2, 2 times 5, 2 times 0, 2 times 7 and this can further be continued as 1, 6, 9. So 13 square is 169. So these are the possible prime factors as 1014 can be expressed in the form of product of prime factors. It is a composite number. So part 1 is verified. So this is verified that it is a composite number. Now let's take the part 2. So considering part 2 we have, so even this when we take it according to the Bodmer's rule, we put brackets and let's evaluate this first. So we'll try to make a multiplication easy. So we'll multiply 5 and 2 first, that becomes 10. 10 multiplied by 7 and 6 will multiply now, that is 42. Then 4 and 3 when you multiply, that becomes 12. So we'll place it in bracket because we didn't finish the multiplication yet, and let's multiply 42 multiplied by 12. So 12 times 2 is 24, 4 and plus 2. 12 times 4 is 48 plus 2 becomes 504. 504 multiplied by 10, that would be 5040 plus 5. This is nothing but 5045. So 5045, we have to look at the prime factorization of it. Let us see if this can be expressed as product of prime numbers. Then only we can call it as a composite numbers. So because it is ending with 5, we know that it is either divisible by 5, it divides it. So 5 times 1, 5, 5 zeros are 0, 5 zeros are 0 and 5 times 9 is 45. And 1009 is a prime number because it cannot be divisible further. So 5 and 1009 are the prime factors for it. As the part 2, the expression that we had in part 2 was expressed in the product of prime numbers, it is a composite number. So as the expression that we took in part 2, we could express it as product of prime factors, it is a composite number. So it is verified that both part 1 and part 2 that we have considered, both the expressions are composite numbers. Now moving on to the second question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round, while Ravi takes 12 minutes for the same. So there is a circular field. So if you are starting from here, Sonia is taking, like to complete one revolution along the ground, she is taking 18 minutes. Whereas Ravi, he is starting from here and to complete one round, he is taking 12 minutes. Suppose they both start at the same time and at the same point. That's what we discussed, right? Both of them are starting at the same point and at the same time, and they go in the same direction. So they are going from same direction. They are starting in the same direction. After how many minutes will they meet again at the start point? So that means even though they are running at different speeds, they are asking at what time they will be meeting at the starting point. To find out this, we consider LCM of two numbers because that is the least possible time that they are going to meet. So when we consider the LCM of the numbers, the prime factors of 12, 2 times 6 is 12, 2 times 3 is 6. Those are the possible prime factors of 12, and we will consider the prime factors of 18 as well. 2 times 9 is 18 and 3 times 3 is 9. So 18 can be represented as 3 multiplied by 3 multiplied by 2 are the prime factors of 18. Now LCM of 18 and 12. So we know that LCM is the product of the highest power of the prime factors. Now when we express this as the product of prime factors, we get that 2 square multiplied by 3 multiplied by 1. This is 3 square multiplied by 2 multiplied by 1. So LCM is going to be 2 square. 2 square is the factor with the highest power and 3 square is one common factor with the highest power. So this is going to be the LCM of 18 and 12. So even if we compare this with the table, 18 times 2 is 36, 12 times 3 is 36. So this is the least possible multiple that occurs for 18 and 12, and Sonia and Ravi will meet again after 36 minutes. So hope you have found this exercise problems informative. So we have even covered the previous exercise questions of this chapter. So I'll be providing links on the top. So please do refer to the links. If you like the video, please don't forget to like, share, subscribe and comment below the video, and subscribe to our channel, The Talk. We will be meeting in the next video with another topic. Bye-bye.